Okay. Hey guys, I hope you enjoy your break. And I'm going to talk a little bit about JavaScript and how we approach it in STRV. My name is Jan. Yeah. Yeah. As you could have noticed before, and from the title of the meetup, we tend to use React.js in case we can. It is a Facebook library that has changed the way we think about web development. We find it best fit for our needs due to its modularity, reusability, and high performance in comparison to other frameworks. Also, thanks to React Native, the approach isn't limited just to web. JavaScript is a library that takes care of only the view layer. It has a component-based approach, which means that app consists of a tree of components which are highly modular and reusable. We write components in two ways. Functional components comes to hand when you don't need any state or lifecycle methods. We preferably write components as functional if it's possible. Here you can see the comparison between components written as a class and functional, or in other words stateless. On the left side you have a component as a class, so you can see that there is a state, so specifically saying username that is being passed into a footer component, which is on the right side. It is written as arrow function in ES6, which I will talk a little bit later. Sorry? So, React introduced a concept known as virtual DOM to web developers. Virtual DOM is an abstraction of actual HTML DOM. You could think of it as of React's local copy of the DOM. As changes are made to virtual DOM, React will batch the changes to the actual DOM as it sees the best. If you look at the picture, you can see how it contains repeating patterns, which can be wrapped into components. For example, on the left side, you have some channels in a chat app. On the right side, you have messages. Let's imagine we want to add another message. Problem with other MVC framework is that they often re-render whole parts of page, even though they don't need to. And they are usually tightly coupled with DOM. On the other hand, React.js, thanks to its virtual DOM, calculates minimal set of changes when going through the current UI to the next one. This is the most crucial part of performance for us. Next significant strength of React.js is its data flow, one-way binding, which means that data goes through components only in one way. In other words, it's passing data down the tree as arguments. Another reasons why we do use React.js here is, for example, its simplicity. It's easy to learn for newcomers, so they can start working very quickly. It uses plain JavaScript and it has well-defined lifecycle, for example. It also has very strong community that provides plenty of great components which are really easy to use, for which we use npm packages. Here as you can see, it's very easy to import select component here, and we can immediately use it inside of, in this case, functional component myform. Another strength of React.js that convinces us to use it is server-side rendering. It allows us to run part of the web app on the server first. For example, to obtain data from API that is needed to render HTML. Server-side rendering consists of three parts usually. First of all, you have API server, which provides you data. And then you have client and web server. Web server renders HTML. A React.js app can run both on web server and client, which has multiple advantages. For example, as has been mentioned by my colleague before, SEO. We write our React.js components using ES 2015, partly also ES 7, and of course JS6 since we are using React.js. Talking about ES 2015, it brings new features to JS world, but it's not fully supported by browsers yet, so we need to use Babel, which just lets us to transpile ES 2015 into ES 5. About some of the features we like to use, it's for example a const that cannot be reassigned, it's a constant. Arrow functions that I have mentioned before. There are two benefits to arrow functions. First, they are less verbose than traditional function expressions. Second, their this is picked up from surroundings, therefore you don't need to bind anymore. We also like to use destructing object, which is on line 6. We like to destruct properties into constants that we use later in a code, which makes it more readable. Also, we like to use template literals, which is the last one. It allows us to use create. It allows us to create, for example, URLs containing variables. They are enclosed by characters called tickback. That looks a little bit like single quotes. About JS6. In JS6 we are mixing something that looks a little like HTML with JavaScript. So it's readable for all developers that are familiar with HTML, for example our backend developers. Note how we treat attributes here, for example class. For example, class as it would be in vanilla JS, here, in vanilla HTML, here it must be class name. About ES7, I said we use it just partly and we use its decorators, which we use as high order components that are replacing mixins for us. It is basically a function that wraps our component with another. As you can see on an example here, on the right side we have decorator connect. On the left side it's a little bit more verbose without decorator. We use them, for example, for connecting Redex's state, which is well readable, as you can see, because we can immediately see what data goes into our component. Also, we split our components into two categories, smart and dumb. About dumb components, they are presential and easily reusable. They use just DOM and HTML DOM markups. They have no dependencies to store, such as Flux or Redux. Also, they don't mutate data at all. They usually don't have state, and if so, then it's just for UI changes. We preferably build them as a functional components. About smart components, they contain just DOM components and no HTML markups. They also provide data for us, which means they might be generated using high order components, so they have connection to Redex's store and actions. Big advantage of keeping components separated into two categories is also that you can keep smart components and replace dumb components for another platforms, for example in React Native. We found very handy usage of resolve loader for Webpack, since we keep our components in different folders. It allows us to import components writing absolute paths. As you can see, it's really easy to set that loader. and thanks to that we can import file in much more simple way. I will talk a little bit also about ESLint, which is a linting utility for JavaScript. The main reason why we use linter is because it brings consistency into our code, which is very important for a teamwork or, for example, when you are switching between projects. ESLint is completely customizable with custom linting rules, and also it allows us to use plugins. Here in STRV we have our own implementation of linting rules done by Robert Rossmann, who is one of our backend guys. Please feel free to make a pull request and make any changes for us. For bundling front-end assets, we picked Webpack. We chose it primarily for its support for hot module replacement. Webpack, yeah, its bundling capabilities are extensive. It allows us to split bundles in various ways. You can even load them dynamically as your application gets executed. It does that through the use of loaders that allows you to target different file extensions. Since I said that hot module replacement is one of the reasons why we've chosen the Webpack, it is a way of exchanging modules in a running application. You basically can update changed modules and you don't need to reload the full page. It highly speeds up our development process. It is possible to achieve some of these tasks with other tools. The problem is that it would definitely take a lot more time to pull off. I already mentioned Redux several times before. So since React takes care just of UI, we need also something to maintain data for us, and that's what we use Redux for. It consists of three main parts. First of all is star, which is a simple object tree. It is easy to debug and understand, but it is only readable. So we need something also to make changes in the data, and that's what we use actions for. Actions are actually just plain objects that are being dispatched through reducers, which are the third part of Redux, and those are simple functions that take state and action. Action tells it how to change the state, and reducer returns the new state. In just React, it would be complicated to have global data that would be accessible from anywhere. With Redux, you can dispatch action or read data from any component you want. Redux also comes with a great set of dev tools that you can install as an extension for a browser. It comes in various UIs. For example, on the right side, you have diff monitor. It shows changes in a store after every fired action. You can also revert each of the action and see instant changes in your page. On the left side you have slide monitor that you can track UI changes while moving the slider. I will just briefly mention also something about React Router, which is a complete routing library for React, which keeps your UI in sync with the URL. Here you can see that it's using JSX components. The main two components are router and route. Even though it might seem like that, router itself is not being rendered. For component route has several attributes, as you can see. there is an attribute path that tells us the URL, how URL will look like, and attribute component that tells us what component is going to be rendered. Route itself can also contain another routes that are presented as its children in the app. You can also add parameters to route which are accessible in component. To make parameter optional, you just surround it with rounded brackets, which is pretty easy. Next component that React Router provides us is index route, which is going to be presented as your default URL. It is also possible to set paths equal to asterisk and put there your component that will represent your 404 page. The last thing I would like to mention is a little bit of React Native. It lets you write native mobile apps in JavaScript and React. You can use standard platform components such as tab bar for iOS or drawer layout for Android. As has been mentioned before by my colleagues, it uses Flexbox for creating layouts. And it will be all. I want to thank you for your attention, and the next one is going to be Jiri Spac with testing.